In this lesson, we will learn how to calculate two more units of concentration, parts per million and parts per billion. If copper is found to be in water at 10 ppm or 10 parts per million, that means that for every 1 million parts, 10 of them will be copper, and the rest H2O. If arsenic is found to be in water at 5 parts per billion, that would mean that for every 1 billion parts, 5 of them are arsenic. We calculate these quantities using mass of solute over mass of the solution, then multiplying either by 1,000,000, or 10 to the 6 for parts per million, or 10 to the 9 for parts per billion. Remember, the solute is the component that is dissolved in the solvent, and it is the component there is less of. The solution is both the solute and the solvent together. Let's find both of these equations on our periodic table. They're in our miscellaneous equations box, parts per billion and parts per million. Let's do a practice problem. A 50-gram sample of industrial wastewater was determined to contain 0.48 milligrams of mercury. Express the mercury concentration of the wastewater in parts per million and parts per billion units. The mercury is the solute, and the 50-gram sample is the solution, which is both the mercury and the rest of the wastewater. When we divide the mass of mercury by the mass of the solution, they must be in the same mass unit. So first, let's convert milligrams to grams. 0.48 milligrams. We're going to want to put milligrams on bottom and grams on top so that our milligrams cancel. Now we need to find the numbers that go in here. We know that there is 1,000 milligrams in 1 gram, or you can write it as in 1 milligram we have 10 to the negative 3 grams. And this gives us 0.00048 grams. Now let's take the mass of mercury in grams that we just calculated and divide by the total mass of the solution, which is the 50-gram sample. When we divide the masses, the mass of grams of mercury and grams of sample, the grams unit cancel in the numerator and the denominator. For parts per million, we will then multiply by 10 to the 6, or 1 million, to get 9.66 parts per million. For parts per billion, we will then multiply by 1 billion to get 9,600 parts per billion. According to the EPA, when the concentration of lead in tap water reaches 15 parts per billion, certain remedial actions must be taken. What is this concentration in parts per million? 1 billion is 1,000 times more than 1 million, so we need to divide by 1,000 to convert from parts per billion to parts per million. And then we would get 0.015 parts per million. When you have a billion parts, 15 of them are lead. But when you only have a million parts, 0.015, not even one of the parts, is lead. So for the second part of the question, at this concentration, the 15 parts per billion, what mass of lead in micrograms would be contained in a typical glass of tap water at 300 milliliters? Here is the equation we need to use. Our PPB is equal to mass of the solute over the mass of the solution times 10 to the 9. We know that 300 milliliters of water is 300 grams of water because the density of water is 1 gram per milliliter. So that is the mass of the solution. So we can substitute that in. We have a 300-gram sample of the solution. And we know that at this concentration, we're talking about 15 parts per billion. So we can substitute that in as well. we are left with trying to solve for the mass of lead using this equation. If we rearrange and plug in our numbers, we get this: 4.5 times 10 to the negative 6 grams of lead are in the 300 gram sample of water when the concentration is 15 parts per billion of lead. The problem asked us to convert to micrograms, which gives us 4.5 micrograms. The little funky U symbol is our prefix or symbol for micro. So there are 4.5 micrograms of lead is the amount that we'd find in that 300 grams of water. The Environmental Protection Agency, or EPA, helps protect us from harm by setting legal limits for over 90 contaminants in our drinking water. These limits are based on the studies that have been done showing at what dose or amount of these contaminants begins to be harmful to human health. Before the EPA, humans would often get sick from drinking water that had extremely high levels of pollutants that caused things like dizziness, vomiting, fatigue, seizures, and in really bad cases, brain damage and death. Here are a few of the limits set for drinking water. In our drinking water, only 10 parts per billion of arsenic is allowed, 15 parts per billion of lead is allowed, and 1,300 parts per billion of copper is allowed. So we can see that copper is much less toxic to us, as our bodies can handle quite a bit more before any negative health effects happen. Many of these limits are actually set well below the amount that first began causing harmful effects to the human body. These legal limits and regulations for contaminants are often reported in parts per billion and parts per million, and chemistry is used to help us better understand how and at what doses they affect human health. So that's why it's important to be familiar with these units of concentration and how to calculate them. You can now complete the entire practice problem packet, including 3.1 through 3.5.